Hello everyone and welcome back to my channel EduSitare. Today we are going to see electric charges and fields, class 12 physics. This is the first chapter of physics and it is very easy and the most important chapter for your board exams and also for competitive exams, where most of the concepts will be asked for competitive exams. So I'm very excited for this video. I hope it is same with all of you also. So without any delay, let's get started with the video. So here is what we'll be learning today. Coulomb's law, that is the first law of electric charges and fields. It is very important law also. And here we have the basic properties of charges. So let's get started without any delay. Now let's see the basic properties of electric charge, class 12, which is very important. Please do mark a star as this question is 100% short question which will be asked in almost all the exams, and these concepts might be asked in the competitive exams. Not might be, it will be asked in the competitive exams. So whatever you study, please do understand the core concept of each and every topics. That is what I say always. Now we'll see the basic properties of electric charge, class 12, physics. First, let's see the types of charges. We all know there are two types of charges, that is positive charge here and negative charge. Positive charge, it is proton. For an example, negative charge, it is an electron. Please don't stick on that positive charge is always a proton and negative charge is always an electron. No. Positive charge may be a proton, a deuteron, an alpha particle, and so on. Here we consider proton. It is the simplest example. Okay. In the Coulomb's law of electrostatics, we saw the force of attraction or repulsion. So, if two positive charges, if it is positive and positive, they repel each other, right? They repel each other. If the two charges are negative, again they repel each other. Why does this happen? They are like charges. Like charges always repels each other. If they are two different charges, now we consider positive, negative charges, they both attract each other. They both attract each other. This is what is the force of attraction or repulsion. This is given here. Like charges repel, unlike charges attract each other. Now let's see the properties of charge. Mainly there are four properties of charges as we see here: quantization of charge, conservation of charge, additive nature of charge, invariance of charge. In class 12 CBSE NCERT textbook, there are only three properties of charges given. Those three are very important. First one is quantization of charge, conservation of charge, additive nature of charges. First, let's understand what is quantization of charges. Now, it is electric charge is always an integral multiple. It means here it is given Q is equal to NE. N may be any number. It may be a positive number or a negative number. Integer means it is positive or negative. As we know, charges can be positive and also negative. So Q is charge. Electric charge is an integral multiple of charges. That is why it is given as Q equal to NE. The value of the electric charge, that is E is equal to 1.6 into 10 raised to minus 19 coulomb. This is also very important. You have to make note of this value. Okay, important one. Next we will see the conservation of charge. Quantization of charge, that is charge is an electric charge is an integral multiple of the charges. That is Q is equal to NE, where N is any integer. Now next one is conservation of charge. It is the total charge in any isolated system is constant. Here we consider isolated system, that is charge inside. Now we'll consider charge inside this box. This box is given here. Charge inside this box is, there are 2 negative charges, 3 negative charges and 1 positive charges. That is, the total amount of negative charges and positive charges inside that box will always remain constant. They do not change, like negative will not convert into positive or positive will not convert into negative. But only one action that takes place inside the system is the charges can be transferred from one place to the other place. Right? Here we'll see an example. There is one box here and another container or a box. Here there is in first box there is only one positive, one negative, one positive. In the other box there are 2 negatives and 2 positive. That is, we are transferring the charge from first box to the second box. Maybe there was already a negative and positive in other box. We have transferred the charge from this particular first box to the second box. That is what it means. That is, total charge in an isolated system remains constant. They can only be transferred from one system to the another system. Now we'll see the additive nature of charge. That is the third property. Additive nature means, additive is something addition. We are adding or summing up all the charges present inside one system. Here there is a sphere. We will consider this sphere. Okay. Here there are how many positive charges? 3 positive charges and 2 negative charges. Now we'll add them up. Here we know they are negative, but we don't know what is the integer or what is the value of them. We know whether it's positive or negative. We know only the sign, but we don't know the value. So we have named it as Q1, Q2, Q3, and this is Q4. Sorry, this one is Q4. So Q total is Q1 plus Q2 plus Q3, so on till how many ever charges present inside that system. Okay, fine. These are the main 3 properties, that is quantization of charge, conservation of charge, additive nature of charge in electric field of the first chapter of class 12 physics. There is another property, that is invariance of charge, which is not given in the NCERT, but let's understand. Having more knowledge is an advantage to us. So invariance of charge, magnitude of charge is independent of frame of reference, that is speed. I know most of you didn't get what the statement is. They are telling the magnitude of charge. Magnitude is Q, right? Q, now you leave all these images. Just concentrate. They are telling Q, it is independent of the speed. How much? Maybe for example, I am the person who is running. I may run at 180 km per hour, but the charge is, I am carrying a charge in my hand and I am running at 180 km per hour. I cannot run at that speed. It is impossible for a human to run at that speed, but I am giving it an example. If I am running and you are the person who is standing near the start of the running race track, I am running at 180 km per hour carrying the charge. So the charge is independent. The charge does not gain speed. It is independent of the charge always. Okay. So charge is independent of the frame of reference. Now mass, for example, mass will change as the speed increases. As the speed increases, as it reaches the speed of the light, the mass increases to its maximum, but it is not with the magnitude of the charge. So simple magnitude of charge is independent of frame of reference or the speed. Right. I hope you all understood this. The basic properties of electrical charges. I have explained it with the basic. If you all have any doubt, please let me know in the comment section below. Let us start with the first law of this chapter, that is Coulomb's law. It is the most basic and an important law. It has been repeated in the board question paper of class 12 in 2014, 2015, 2017, 2018, 2019 and 2020. So it is very important derivation. It will be asked. It is a must question. So please understand the law. So let's get started with the video. First, define Coulomb's law. The electrostatic force of attraction or repulsion between any two static point charges is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them acting along the line joining the two charges. This is the definition, or it is the statement of the given law. First, let us try to understand the statement. As per the statement, the electrostatic force of attraction between any two static point charges. We have considered 2 point charges, that is Q1 and Q2 here. I have drawn it here as you all can see. Two static charges. There are point charges. They are not huge charges. We are considering two static point charges. Static means anything that is at rest. Now the charges are not moving. They are not repelling or attracting anything. They are at rest. So the force they are telling the electrostatic force of attraction or repulsion. If it is attraction or repulsion, it is possible only between two like charges for repulsion case, two unlike charges in the case of attraction. So here we just consider Q1 and Q2, not plus Q or minus Q. That we will consider in electric field or capacitance and other derivations. Here it's just two static point charges Q1 and Q2. Is directly proportional. What is that? The force is directly proportional to the, what is force? Force is something when we push or pull an object. We push some object with a force, then work is done on that object, right? So the force between, that may be attraction or repulsion, as I told in two cases, is directly proportional to the product of the magnitude of the charges. As we can see here, it is directly proportional to the product, that is Q1 dot Q2. Product is always given as dot product. F is directly proportional to the product of the two static charges and it is inversely proportional. This is done. This is the first step, right? Then it is inversely proportional to the magnitude of, inversely proportional to the square of the distance between them. Which are the two charges? One second. These are the two charges and the distance between them, I'll consider it as R. What is R? This distance is R, is what is R I have considered. So it is inversely proportional to the square of the distance between them, right? This is the second equation. Combining both the equations, according to the law, we get F is directly proportional to the product of the charges, inversely proportional to the magnitude of the charges. F is directly proportional to Q1 Q2 divided by R square. To remove the proportionality constant, we take a proportionality constant which is K. As of now, we don't know the value of K. It is just some constant. F is equal to K Q1 Q2 by R square. Later, K value was found to be 1 by 4 pi epsilon naught. This is very important. K is equal to, it is given as 1 by 4 pi epsilon naught. Later we consider values also for solving the problems. That time the value of K is 9 into 10 raised to 9. This is important. So the Coulomb's law, the final equation of Coulomb's law is F is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R square, or 1 by 4 pi epsilon naught can be taken as 9 into 10 raised to 9, that is F is equal to K or 9 into 10 raised to 9 Q1 Q2 divided by R square. Now what is epsilon naught? This 1 by 4 pi epsilon naught which is given, it is completely a constant, where 4 is also constant, pi value is 3.1422 by 7. Then we have epsilon naught. Epsilon naught value will be knowing further in other problems. While solving problems, you can take the value. It is 8.85 into 10 raised to minus 12. So K is 1 by 4 pi epsilon naught, which is the constant. I hope you all understood this. Again, let me tell you the Coulomb's law in the simplest form. That is, the electrostatic force. Electrostatic is very important. Force of attraction between 2 point charges is directly proportional to the product of the magnitude of the charges. You can take it as magnitude also, and inversely proportional to the square of the distance between them, as this magnitude cannot be negative value. Inversely proportional to square of the distance between them, and the force, it acts along this line. The force acts along the line joining the 2 point charges. So I hope you all understood this derivation. It is the most basic and very important derivation of this chapter. If this video brought you value, smash that like button, subscribe for daily masterclasses, and share it with a friend who needs to see this today. And bye bye, take care until the next video.